how to compound, interest, and also how to discount. So compounding meaning how to find a future value of today's investment. Like if you invest, let's say, $100,000 today for 10 years, how much money you're going to get cumulatively at the end of the 10th year. So that's for compounding, and of course it's very, very important. One of the most important benefits of it is to know the value of your investment in the future. Okay, so we also looked at discounting. Discounting is very useful for investment appraisal decisions, for long-term investment decisions. Like if you want to invest money today and you expect to realize some inflows in the future, before you can be able to take any decision, you have to discount, you have to bring down the future cash flows to their today's value and compare them so that you can be able to take a meaningful decision. Okay, so those are the techniques we looked at. So I gave you an assignment, which was, I think, on Slogan Limited, on NPV analysis. So, so we're going to do NPV analysis proper today. And we're going to do one small question. We're going to work it manually, and we're going to work it using spreadsheets formula for NPV calculation, which is a lot faster. Okay, so we're going to show you that. And then afterwards, we're going to look at an exam type question, which is a full-blown past ACCA question. And then afterwards, we're going to look at IRR. IRR is actually very, very, very similar to NPV analysis, except that there's a formula that you need to know after calculating the NP, after calculating the present value for two different rates. Then you need to substitute whatever you have in that formula to calculate your IRR. Okay, so those are the things that we're going to look at. So please bear me out. If you have not eaten, please try and eat so that we finish this. I mean, we've been on this for a long, long time now. So let's try to finish it. Let's try to bear, and finish it today, inshallah. Okay, is that okay, everyone? So we all know what is expected of us. Let me switch my phone off so that I don't get distracted. So, ready to go? Ready to study? Right, so where did we stop? Are you ready to go? I know we are all tired. I have worked just like you've worked the whole day. Yes, and I'm still at the office, hungry. I'm not very hungry, but I was just munching here and there. So, but let's all beer. Okay, right. Is that clear, everyone? I'm sure you are tired of seeing my face, so you want to change now. You're tired of seeing a Jaranka face, so you want to. Are you not tired of seeing a Jaranka face, Mr. Kaur?
Not yet, not yet. Maybe after today.
After today, okay, that's fine. At least, so I have a day to go then. Okay, so we've spoken about this last class, so let's look at it again. What do we mean by NPV? NPV simply is the difference between discounted cash inflows and discounted cash outflows. Okay, so like I said during last class, our decision is as follows. if the net present value that you've calculated is positive, we go ahead and advise management to execute the investment or the project. If, on the other hand, the NPV you calculated is negative, you advise management not to go ahead with the project. And if NPV is nil, then in that case also you advise management not to go ahead, because there may be some inherent risk that may not be apparent during analysis time. Okay, so we all know this, right? So let's see, if it is positive, if it is negative, if it is zero, we've spoken about it. Good. So what are advantages of net present value method? The most important advantage is it considers time value of money. And time value of money means money today is not the same as money tomorrow. If you have $1,000 today, what you can do with that 1,000, if you have that 1,000 in a year, you will not be able to do that, simply due to inflation. I remember when I was going to high school, I got a scholarship, government scholarship, but I remember the school fees a year is $37.50 in 1987. Okay, the school fees was $37.50. If you tell that to people of this generation, they'll think you're talking, and that's the case. Now look at the private schools, for example. The school fees per term, schools like CBEC and Marina and stuff like that, per term, you pay more than $10,000. So, but when you look at $37.50 in 1987, it's a big amount, because I know in those days a bag of rice was not more than $100. Around that. Mr. Core, isn't it? Somewhere around that, isn't it? $100. I know it's not more than $150. Yes, but now a bag of rice is about
somewhere.
Yeah, the bag of rice is around 1,400, 1,300. If you want Saddam, 1,800. Very expensive. So time value of money is very, very important. So the most important advantage of the net present value method is it considers time value of money. And of course, it considers all relevant cash flows of an investment. Unlike the payback period considers only cash flows within the payback period, and any cash flow after the payback period is not considered. Okay, and since we look at time value of money, since relevant cash flows and everything is considered, risk is incorporated into decision making. So we are aware of the various conditions. There could be a risk of cash inflows not forthcoming in the future and stuff like that. So all those are considered when we are taking decision. And fourthly, it provides clear and unambiguous decision. Okay, very simple. NPV positive, take it. NPV negative, reject it. NPV zero, reject it. So it's clear cut. Okay, so these are some of the advantages of NPV analysis. Okay, so we looked at Slugger Limited, isn't it? This one is a different one. Let's do this quickly. And we're going to do it twice. We're going to do it manually using our calculator. Of course, we're going to use Excel. And then two, we're going to do it using our Npv formula. Okay, it's a lot faster. So that's why it's really, really important you consolidate on your Excel and your Google Sheet. Okay, very, very important, because Now it is people don't use this long formula, you know, find your cash flow, find your discounted DCF, discounted cash, how to call it here, your discounted cash flows, you know, present values and all these things. You know, the calculations is just too cumbersome. But you do one formula and then the answer is just out there. Okay, so this is what we're coming to look at. So, but first, let's calculate this manually just to refresh, our mind. Okay, so please make sure you screenshot this before I move. Screenshot it before I move. I'm going to go back to the spreadsheet so we can answer the question. Excellent. Right. Okay, are you following? Have you got the question in front of you?
Yes, we have it.
Excellent. Yes, that's the one. Good. So I'm going to open a new worksheet. And then I will call it, I'll call it what? NPV Q1. Okay, I just call it NPV Q1. I just call it Q1 just to identify. All right, so I'm going to zoom it to 150 so that you people can be able to see it clearly. Okay, so we're going to go fast on this because we've done discounting, and I've given you an assignment also on discounting. So it's a quick one. And of course, we've been given the table to use for calculating our, how to call it, our cash flow. So we just say company limited. The name of the company is not given to us, so we can just give it any name. Okay, so this is the table. The first column is the year. You have the cash flow. You have the DF, the discount factor at 16%, so 16.5%. Okay. DF at 16.5%, and then we have our PV. So like I said in exams, don't bother yourself to write this in full. You haven't got time. If you say PV for present value, DF for discount factor is all acceptable. So don't worry. Right, so we're going to start from year 0. Okay, so who can tell us what to, what formula can we use here so that we can have our automatic numbering each time we have our cash flow here? Who can remember that? Okay, so I'll refresh your mind. I will say equals if error, okay, sequence, count A, then we're going to count A. This time around, we're going to start from year 1, which will be from C6, isn't it? Yeah? Is that clear? Okay.
Yes.
C6 to where? C6 to where? To put the feature.
C9. C10.
No. We are going to put the feature into account. Let's say this is 1,000 years. So okay. C6 to?
Infinite.
How will you say infinite to
C? Just C alone.
Just C, excellent. C6 to C. And we close our bracket, so that will close this first bracket. We close our second bracket, that will close this bracket, right? Then we say comma. If there is an error, what to do? We do our double inverted comma open. We hit the space bar 1, double inverted comma close, so that we can return a space if there is nothing, and then we close our bracket, we enter. So if we enter, nothing happens, but once we type, something will happen. Okay, good. So we'll have our cash flows. Yes.
Good evening. Please, sorry to take you back. Would you mind repeating, please? I got lost at some point.
You got lost, Francis. Okay. Right. So actually, I've done this many times. This is we're trying to do an automatic numbering. Okay, automatic numbering using the sequence and count A. The if error is a function we use in a situation whereby the cells are empty, so that we don't return any hashtag errors and stuff like that, so that hashtag errors are not returned. Okay, so so this is the formula here. So we say equals if error. You can see the formula here. Then we open the bracket. We say sequence. Sequence is just from the English word sequence. If something is in sequence, that means it's in order. Okay, count A. The sequence of count A means to count the number of cells and stuff like that. So where do we want to count? We want to count from C6. In fact, we can start from C5. Let's start from C5. Okay, so we want to start from C5 all the way to C, and what that means is in infinite. Okay, so if we put all the way to C100, if we have any cells beyond C100, it's not going to capture it. So if you say C5 to C, that means everything that is between C5 to the last cell on the C is going to capture it. Have you seen it, Francis? Then now we close our bracket once to close the cell range, and then close our bracket twice to close the count A, and then we do our comma meaning if there's an error in this formula, what to do. If we want, we can put something here, in between here. We can say no numbers. We can say no numbers entered. E-N-E-E-R-E. So you can say no numbers entered, for example, then you enter. Okay? So you see, now it's saying no numbers entered. So if we type anything, see, it's going to give you 1. You type something, it's going to give you 2. You type something else, it's going to give you 3. Can you see? Is it understood, Francis?
Yeah, thank you. I got it. Thank you.
You got it. Good. Okay, so that's just to refresh your mind on the sequencing. Yeah, just to refresh your mind on the sequencing. Yeah. By the way, I want to say this. On Saturday, I had a class with the UTG Debating Association. Like I said, I did not organize it actually. It was their executive who organized it. They've been following me for a long time, and fortunately, we were able to do it. How to call it on Saturday. So even after this class, if you want, we can do a special one, which will be a comprehensive one later in the future. Maybe after taking your exams and so on. We could organize one, okay, free of charge. So just like I did for these people, okay. So how to call it? Karamo, you can take note of that. Maybe later on we could organize that, okay? Just before I forget.
No problem.
Okay, good. So now our first cash flow for year 0 is 280,000. For year 1 is how much?
149,000.
149,000.
128,000.
128,000.
84,000.
4,000.
So 70,000.
And 70,000. The formula will be done in such a way that it will show year 5 and you cannot come and delete it here. Okay, but don't mind, it's going to show it automatically, so you just leave it out. You know that you're going to stop at year 4. Okay, so we're going to do our formatting. So we click on this, we align to the right, and we're going to take our number formatting to our financial number formatting, 0 decimal place. Okay, so, right. The discount factor at 16.5. In year 0 is going to be how much? In year 0, what will be the discount factor?
Should be 1.
It's going to be 1. Should be 1.
1.
Should be 1. Good. Should be 1, because any number multiplied by 1 is 1. Okay? And the discount factor, always take note of that. The discount factor should always be less than 1. Always.
It's 18 hours.
Why should it be less than 1? Why should the discount factor be less than 1? Why should the discount factor be less than 1? Let me format this to 3DP in the first place. Why should it be less than 1?
Because 1 is like 100%. So anything that is less than 100 should be less than 1. 1
is 100%. Anything less than?
Anything less than 100% should be less than 1.
Anything less than 100% should be less than 1. That's a nice one, I'm saying it. You have the idea, but it's not being said properly. Yes, you can try. Why should the discount factors be less than 1? Look, it's simple. We know if you multiply any number by 1, it gives you that number. What about if you multiply any number by less than 1? What will be your result? Your result will always be less than that number. If you multiply any number by more than 1, you are going to get more than that number. So if you multiply any number less than 1, you are going to get less than that number. Is that clear? So always take note of that. If you do your discount factor, you multiply by here. For example, you multiply this. Let's say you have whatever discount factor, you multiply it, and then you have 150 something. Straight away, know that you are wrong. Okay? Because it can never be more than 149. That's why you are discounting. Discounting means you are bringing it lower. Okay? This is a cash flow in the future. Okay? You want to bring it down to today's value. Naturally, it has to be lower. Is that clear? Okay, so now, how are we going to calculate our discount factor for 16.5% at year 1?
It should be 1 divided by 1.65 to the power 2.
Equals 1 divided by
1.65.
1.65
To the power 2.
all raised to power 2. What do we use to do the raised to power in our calculator?
Yes. You're going to shift and 6.
That's on the computer. In exams, you are going to use your calculator. Please note that.
Yeah, the key is there. The sign is there.
What's the sign? In some newer calculators, it's just the same as the one on 6. Just like V reverse. And in some older calculators, it's like x to the power y. Okay, take note of that. It's like x to the power y. Okay, so 1 divided by 1.65 raised to power Raised to power what?
2. 2.
No, 1.
It should
For
be
the
raised to the
first
power
year.
1.
Raised to power, just click on the cell.
Raised to the power 1. And also, it should be 1.165, not 1.61.
Huh?
Yes,
It
what he's
should be
trying to say is it should be
1.165.
1.165.
Exactly. Good. Good. I thought you're not going to discover that. What's the difference between 1.65 and 1.165? Is it 1.165?
1.1.
Yes, 1.165.
Yeah.
Yes, it's
1.65 is
1.165.
65%, and 1.165 is 16.5%.
16.5% grossed up. Okay, so that's 16.5 grossed up. So good. It should be 1 divided by 1.165. So 1.165 meaning 16.5%. 16.5% is 0.65. 0.65 plus 1 is 1.65. Sorry, 1.165. Is that clear? So 1 divided by 1.165 raised to power 1. Okay, so once you do 1, it's going to ask you for an autofill. So yes, we'll accept autofill. Okay, but not for year 5. So this is what we have to 2 decimal place. The first one should be 0.86, 0.74, 0.63, and 0.54. Is that clear? Because I think the question asks us to take it to 2 decimal place. So look at them. Each and every one of these, is it more than 1 or less than 1?
Less than 1.
They are all less than 1. So all the discount factors are going to be more than 1. The annuity factors, we are not doing annuities here, but in future, if you do annuities, annuity factors are always more than 1. Okay? So now let's find the present value of these numbers. So we say equals this multiplied by their discount factor, and it's asking us to replicate. Yes, we're going to replicate. See how fast this is. And I'm going to do my formatting using the financial formatting, but then I'll take it to 0 decimal place. Okay, is that clear, everyone?
Yes.
Okay, so we're multiplying each and every one of this. We're multiplying it by, okay, we multiply the cash flow by their discount factors so that we can have our present values. So what will be our NPV? Our NPV will be, okay, our NPV will be the total of this. So this is our NPV. Is this correct?
No.
No.
Why? Why is it not correct?
The 4th year should be discounted.
There you go. No, the 4th year should be a negative number.
A negative
because it's
side.
an outflow. Because it's an outflow. Okay. If you use your calculator, actually, you will not get exactly this number. There will be a little bit of rounding of difference. Okay. So don't mind. It's still correct. There will be a little bit 100 plus 200 plus rounding of difference. Like if you are using your calculator, what you are going to do is you are going to find the the how to call it, the DF of this 0.86, you write it down. The DF of this 0.74, you write it down like that. Then after you clear your calculator, multiply this by that, and then that will round it up. So if you are using calculator, maybe you'll get something like 128, 140 or something like that. But that's just very close to this. Okay, so don't worry if this is different from what you're going to get. In exams, once you follow the techniques, you will not miss out a single mark. Is that clear? So our NPV is 33,333. But when you use a calculator, you get something like NPV of 33, 500 something. There's a difference of 200 or something like that. Okay, so if you have a difference like that of talking of cash flows in thousands, that's not significant. Is that clear?
Yes.
Yes.
Excellent. Good. So now what we're going to do is, yes, someone wants to say something?
Yes, the first one, I want to see review the formula for the first one.
Here, this one?
Yes, the formula, no, this one, the DF percentage.
Okay, I'll show you all the formulas. Okay, these are all the formulas.
The up one?
I said I have shown you all the formulas. Can you see them?
Yes, I can see it, but the other one I haven't seen it, where you have 200.
Where I have?
1.00.
This one?
Yes.
No, there's no formula there because the discount factor for year 0 is 1, so that's why we just type 1.
That's one. That is it. 16 over 16.5 over 16.5 times to power 1.
Well, this is at year 0. Year 0. Well, if you want, you can do 16.5 divided by 16.5. It will give you 1, so it's the same. But actually, we know naturally that at year 0, we don't discount because by discounting, you're trying to find the value now, and your outflow will definitely be value now. Is that clear?
Okay. Yeah.
Okay. Excellent. So we're going to use our Npv formula. We're going to use our Npv formula to calculate our NPV. Okay, is that clear, everyone? I'm going to make this bold. Okay, so we're going to use our Npv formula to calculate our NPV. Okay, so now to calculate our NPV first, we must have our parameters down. Our parameters, of course, are here. We have the outflow, we have the inflows, we need to get the discounted, we need to get the discount rate on its own, or we can include it in the formula. So let's say we have our DF, discount factor rate. Our discount factor rate, we're going to make it a percentage, which will be 16.5. Okay, so we've got all the parameters. So to use an NPV formula, so I'm just going to say NPV. Okay, so we're going to find NPV and we're going to find it here. So very simple. You go equals NPV, as you can see on NPV. Okay, it will return NPV for you. Okay, so you choose NPV. Once you choose NPV, can you see it has given you all the parameters? So the first part of the formula is the discount rate. And the second part is cash flow 1 and then cash flow 2, like that. So the cash flows that are the same, we're going to put them together, and the cash flow that are not the same are also going to be put together. Okay, so so we say equals NPV. The first one is the discount rate. What's the cell reference for discount rate? What's the cell reference for discount rate?
C14.
Sorry, the DF rate, yeah?
C14.
C14. So we click on C14, we say comma. Then the cash flows that we have, the first set of cash flow are the cash inflows. Our cash inflows are here, so we're going to click from here all the way here. Then we close our brackets. Okay, we close our bracket. Then the last cash flow will be, how to call it, will be a negative. So we'll just do a plus, and then we click on that cash flow, and we enter. So once we say enter, look at what happened. Why has it given us this back? It's interfering with this one. Oh, it's the numbering. Okay, don't worry. It's because of the way we did the numbering. Okay, so what I'll do is I will, you know, you remember we did the numbering. So the numbering, the problem with the numbering is if you do anything within its error, it just doesn't accept it, you know, because of the sequence we use. So I'm just going to do the copy and paste special values so that we do away with the formula. We have only our years. So I just do copy. Then I go inside here, I say paste special values. Now there are no formulas in the numbering, so I can just delete this. Then now let's go back and do our NPV formula. We say equals NPV. We double click on the NPV. This is our discount rate. Okay, sorry, what are you doing? Oh. Equals NPV. We choose our NPV formula. Okay, let me close this. Our first is the discount rate, comma, the cash inflows are from year 1 to year 4. Okay, we close the brackets. Okay, then we add the outflow. We say enter. So you see, it has given us the same answer as this. So can you see? Only do one formula, you have all this. This one, you have to do all this, calculate their discount factors, multiplied by present value. No. If you know your NPV formula, simple. Can you see?
Yeah, it's short. Huh?
It's very, very, very short. So I'm going to copy. I put the formula here. I copy. So I just come here and say NPV formula. So the NPV formula, in order for it to feature here, we must prefix it with a single inverted comma. Otherwise, if you put it there, it's going to show as a formula. Okay, so this is our NPV formula that we used. Okay, are we together? Is it clear, everybody? Is it clear, everybody? So this is the way we calculate our NPV easily using our discounted cash flow techniques. Of course, using our 16.5 discount factor and multiplying it to get our present value and then adding them. But if you use an NPV formula, you only apply the formula and then you get the answer straight. Can you see? This answer here is the same as this. Are we together?
Yes.
Excellent. Excellent. Okay, so any questions before we move? Any questions before we move? I'm going to share this worksheet with you, so don't worry. I'm going to share it with you. I'm going to download it after the class, and then I'll share it with you, yeah?
Mr. Pavana?
Yes, ma'am. Go ahead, Basim.
In the exam, will you need the calculation of